exponent x. A logarithm, an exponential function is always written in the form y equals a exponent x. Then this exponential function can be translated into a logarithmic function where we go in the opposite direction, where we will say x, start from here, x equals to log a y. So in effect, this and that is the same. Of course, if you have to find the inverse, you know that we have to interchange x and y. So y equals to log x. And there is something that you have to know. Oh, okay. Sabelo, if you can see, let's see. Can you see the screen?
Yes, I can see the screen very well.
Okay, I'm writing here. Can you see it?
I can see perfectly there.
Oh, okay. Okay. Okay, then you're going to write there. So, as I said, we have y. An exponential function is always written equals to y equals a exponent x. Then, an exponential function can be converted into logarithmic function. So we start from here. We write it like this: x will be equals to log a y. So if you are asked to find the inverse, you know that you just interchange x and y. And then this and that is the same thing. The two are the same thing. This is when it is in exponent form, and this is when it is in logarithmic form. Now, secondly, to the last one thing that I would like also to tell you, this a exponent, this this base a has got some properties that you need to know. The first property is that this is always greater than 1. This a is always greater it's no it is it's not that way. It is this a is always greater than 0, but it can never be equals to 1. So that means that the base here can never be a negative, and it can never be 1. It can be any number in the real number system except a negative and a 1. Because if it's a negative and it's a 1, it's no longer an exponential function. It's one very important point you must know about an exponent. Is any questions there? Is any questions there? Okay. And in the absence of no questions, in the absence of no questions, then we can go on. So we have to note that let's go to the next page. Okay, good. Then when we are asked to sketch logarithmic an exponential function where we have y equals to a exponent x. What we have to know is that as the a becomes smaller, the graph veers off to the left. So that here we have y equals to 4 exponent x. It is here. When it became 3 exponent x, it is coming up to the right a little bit. When we have 1 5 exponent x, is getting all down to the x. But also we have to know something, that this function, the exponential function is given by y equals to a exponent x. Now, there can be a constant, say b. There can be a constant, say b, in front of the x. There can be a constant. There can be a constant, say b, in front of the x. Now, so we can have, say, y equals to b times a exponent x. Now, anytime that b is positive, the graph is always above the asymptote of the graph. And here, let us remember that the asymptote is nothing here. So the asymptote is like it's plus 0. So the asymptote is y equals to 0, which is the same as the x-axis. But you have to note that anytime that the number in front of the exponent is a positive number, the graph is always above the asymptote. And if the number in front of the exponent is a negative, your graph is always below the asymptote. Your graph is always going to be below the asymptote. Then you also have to note that you can have an increasing function. You can have an increasing function, and you can have a decreasing function. Now, when we have y equals to 4 exponent x, this graph is an increasing function in the sense that as x approaches infinity, y approaches positive infinity. Anytime that x approaches negative infinity, y will approach 0. As you can see. If you can have something like this, y equals to 1 over 4 like this, all exponent x. You have to note that we can simplify this like this. Y equals to 4 exponent minus x. Now this graph is a decreasing function. So when you plot a graph like this, time the graph is going to look like something like this. It's going to look like this, in the sense that as x approaches positive infinity, y will approach 0, or the asymptote. And as x approaches negative infinity, y will approach the positive infinity. So you must know these dynamics about. So these are examples of a decreasing function, as you can see here. And these are examples of an increasing function. Is any questions so far?
No questions, sir.
Okay, good. Okay, so you can go on. Then we also have to note that whenever you have y equals to a exponent x, remember that the general form of the general of an exponential function is written by this: y equals to let me write again. General form of an exponential function is written by y equals to p times a exponent x plus c. So we always have to notice that y equals to c is always the asymptote. Y equals to c is always the asymptote. So if you write a function like this, y equals to 4 exponent x, the meaning is that your b is equals to 1. That is, the coefficient of the exponent is equals to 1. And your c is equals to 0. And now your asymptote is always y equals to c. That means that your asymptote is going to be equals to y equals to 0. In that case, such an exponential function is not going to have an x-intercept because we know that the graph can only approach an asymptote, but it cannot touch the asymptote. So in that case, your c is going to be your graph can only have a y-intercept, and your graph cannot have an x-intercept. And we also have to note that anytime your b is greater than sorry, yeah, I'm using a. So anytime that your base, which is a, is greater than, your graph is an increasing function. And anytime that your a, that is your base, is between 0 and 1, your graph is a decreasing function. You must take note of that. Anytime that is base of the graph, I'm saying the base because we are using different letters here. So any the base of the exponential exponent is greater than 1, you always have an increasing function. And anytime that the base of the exponent is between 0 and 1, you are always going to have a decreasing decreasing function. As we can see from here. Here, your base, here the base is b. But that your base cannot be 1, your base cannot be the negative. Your base is always greater than 0, it's always positive, but it cannot be 1. So here, if your base is greater than 1, your graph is an increasing function. And if your base is between 0 and 1, your graph is always decreasing. Your graph is always a decreasing function. It's three questions there. Any questions there? Any questions? Okay, we can go on. Okay, good. So as we can see here, we should also be able to note some how do you call it, properties so of an exponential function. So for instance, we have y equals to 3 exponent x. This is an original exponential function. This will be an original exponential function where it will not have an x-intercept because your x-intercept will be the same as will be an your x-axis will be an asymptote, but it's going to have a y-intercept of 0, 1, 0, 1. Then it's going to be an increasing function because the base is greater than 1. Because the base is greater than 1. So we can use the original function, which is y equals to 3 exponent x, to translate to get other graphs. So you have to note that if you know the original function and you are asked to plot y equals to negative 2 into bracket 3 exponent x, you need to see that when you multiply the graph by what do you call it, a constant, which is greater than 1, the graph is going to expand a little bit to the right. Then because of the negative, once you have negated the whole function, it's going to reflect on the x-axis. It's going to reflect on the x-axis. So this is just like what do you call it? This is just like the translation of graphs we did in Unit 3 when we met during the face-to-face on campus. For example, it's like this. When you have y equals to 3 exponent x, if you negate the x, the graph will reflect. For instance, the original graph is like this. The original graph is like this. And where here is equals to 1. So we have the original graph like this. So if we negate the x, we are going to have y equals to 3 minus x. So once you negate the x, the graph will reflect the x, y axis, sorry. The graph will now become like this. Here will be 3 minus x, which is decreasing function. And one will ask, but this 3 is greater than 1. So when you have 3 minus x, it's the same as 1 over 3x, which is the same as 1 over 3 all exponent x. So it makes the base to be between 0 and 1. Then in the same way, if you negate the y, it's like you have negated the whole function. So if you negate the y, you are going to have something like this. And the original function is y. The original function is y equals to 3 exponent x. So if you negate the y, you are going to have y equals to negative. Remember that negative is very independent of the exponent. Negative a exponent x, because the exponent, the base can never be negative. So the negative is just a number in front of the exponent. So in that case, your graph is going to now reflect. The original graph will be like this, where you have this had to be 1. So the original graph will be like this. So 3 is going to be like this, an increasing function. So now that you negate the whole function, now the graph is going to reflect on the x-axis. You have negated the y, and now the graph is going to go like this. So you must know these dynamics. It's the same as the calculation that we did when we do Unit 3 back on campus. So in the same way, when you multiply the exponent by a number greater than 1, the graph is going to expand a little bit. It's going to be expanding. Then if you multiply by a number between 0 and 1, it's going to be shrinking. So here it's multiplied by a number greater than 1, so it's expanding to the right. When we multiply by a number between 0 and 1, it will shrink to the left. That order. So we are still looking at translations and how a graph translates. Is there any questions? And so in the same way, if you have um, um, y, so in here the original graph is like this: y equals 3 exponent x. And you can easily use this original graph y equals to 3 exponent x to sketch a graph y equals to minus 2 into bracket 3 exponent x minus 2. We have to simply know that this graph is going to go through 3 translations. It's going to expand a little bit to the right, then it will reflect on the x-axis, then after that, it will go down by 2 units. So when it goes down by 2 units, you have to know that now your asymptote will no longer be y equals to 0, but now your asymptote is going to be y equals to minus 2. Is any questions? Please, any questions? Please, any questions? Please, any questions? Let me go on. Please, it's important to understand this dynamic because those are the questions that are being asked. It's important to understand them. Then, next thing I would like to talk about is the. Okay, somebody has said something. Let me see. Okay, good. Okay, good. Then also we must also understand the dynamics, domain, and range of an exponential function. Let us look at the original function. The original function, let us note that 2 exponent x be 3 can be 3 exponent 4 exponent anything. Original function. You should be able to know how to do the original function in which the translation. For argument's sake,
So you're breaking.
oh, okay, sorry. Is it fine?
No,
Can
so
you hear
it's
me now?
like you blocked us. Yeah, now we can hear you.
Okay, thank you. Um, so we have y equals to 3 exponent x. That's the original function. So I'm going to have this like this. Then here the y-intercept is going to be 1, 0, and 1 because when you put x equals to 0, you're going to have y equals. And this graph is going to be an increasing function. It's going to be an increasing function like this. So you have to note that for an exponential function, the domain is always from negative infinity to infinity. Always. The original exponential function. Domain is from negative infinity to positive infinity. Then, if the graph, um, if the number in front of the exponent is positive, if the coefficient of the exponent, the coefficient of the exponent, coefficient of the exponent is positive, greater than 0, your range. Okay. If Tabelo, is it clear now?
Yes, it's clear.
Okay. If the coefficient of the exponent is greater than 0, then you have to know that your range is always between your asymptotes, not inclusive. Your asymptotes, the number for the asymptote, not inclusive, positive infinity. But if your coefficient of the exponent is negative, which is less than 0, then your range is always between negative infinity not in and the asymptote not inclusive, and the asymptote not inclusive. So let's look at this example. Now, if we look at this graph, the original function is y equals to 3 exponent x. Y equals to 3 exponent x. So in this case, you can see that coefficient of your exponent is positive. The coefficient of your exponent is positive. In that case, your domain will still remain from negative infinity to positive infinity. But your range is going to be, remember that in this graph, your asymptote is going to be y equals to 0. So your range is going to be the number for the asymptote, not inclusive, 0 to positive infinity, like this. Now, if we have this one, a graph like this, minus 2 into bracket 3 exponent x. This time, the number in front of your exponent is negative. The number in front of your exponent is negative. So in this case, your range, your domain will still remain from negative infinity to positive infinity. At your range, this time, because it's a negative here, it means your graph is going to be below the axis. So your range is going to be now start from negative infinity to the asymptote, which is 0, like that. So you must know this small dynamics. So in the same way, if we have something like this, y equals to negative 2 into bracket 3 exponent x minus 2. We have to see that our domain is going to be from negative infinity, still negative infinity to positive infinity. Now, because of this negative 2 here, that means that your graph will definitely be below the asymptote. So your range, and let us remember that in this case, our asymptote is now y equals negative 2. So your range is going to be from negative infinity up to the asymptote, which will be negative 2. Please, any questions there about? So you just have to generalize this in your head. Once you generalize this in your head, no matter which question they ask you on domain and range, you can easily answer the question. You can easily answer the question. So are there any questions, please? Are there any questions, please?
No questions.
Okay, thank you very much. Okay, good. So we have also talked about the translations. You have to know how the graph translates. If you negate it if you negate the y, it reflects on the x-axis. If you negate the x, it reflects on the x-axis, and all that. So when we can look at this graph, we have to know that the original graph is y equals to 3 exponent x. And this graph has gone through about 4 translations. First of all, if you multiply by 2, it's going to add a little bit the right. Then if you negate it, it is going to reflect on the x-axis. Then -1. -1 simply means that it's going to shift to the right by 1 unit. Then -2 simply means that it is going to go down by 2 units. That is the reflection. But the domain and range, the principle still remains the same. That our domain is still going to go from negative infinity to positive infinity. Our domain is still going to go from negative infinity to positive infinity. And because of this negative 2 here, our range is going to start from negative infinity to the asymptote, not inclusive, which in this case is minus 2. Any questions there? So with this, yes, Zulu.
Can you please explain again the function of that -1? I missed it.
Remember that when we were back at school and we were doing translations of graph. You remember that we said that whenever you add to the x, the graph will shift to the left by the same unit. Understand me? Whenever you subtract from the x, the graph will shift to the right by the same units. You remember that? And we also say that when you subtract from the y, the graph will move down by the same units. When you add to the y, the graph will move up by the same unit. You remember that?
Yes, sir.
So in this case, see that the x, you have subtracted 1 from the x. I've seen that. Which means that your graph is going to shift to the right by 2 units. Sorry, by 1 unit. I'm very sorry, 1 unit. So in the same way, if you add to the x, it will shift to the left by 1 unit. Does it make sense?
Yes, sir.
Okay, good. So here, if we look at activity 8.1, they have asked us to sketch the following graphs. So in this case, you simply have to know the original graph. The original graph is the same. We are going to that is y equals to 5 exponent x. We have to know that here is going to be the y that is going to be y 0 and 1, and we have to know that the our asymptote will be y equals to 0, which is the same as the y equals to 0, which will be the same as the x-axis. Then our graph is going to go like this, increasing function. So now, if they ask you to sketch negative 5 exponent x, you have to note that first of all, the graph will expand a little bit like this, but like this, and that is 3 times 5 exponent x. And when you negate it, the graph will now reflect on the x-axis. So here will be where here will now be 0 and -1. 0 and -1. So here is going to be y equals to negative 3, 5 exponent x. This. So in the same way, if they say +2, +2 simply means that now this graph is going to go up. This graph will go up 2 units here. So we have 2. So the graph is going to come 2 units like this. We've seen that. Where your asymptote is now it will your asymptote is now going to be y equals to 2. Y equals to 2. Please let me draw it again. Let us remember that now we have this graph. We have this like this. So when we reflected with -3, it will be -1. So our graph is going to be like this. So here is -3 times 5x, 5 exponent x. So if it says that +2, now this point to go up 2 units, so you're going to have -1 up to 0, 1 unit up to 1. Your asymptote, which is now y equals to 0, will now become y equals to 2. So your asymptote is going to come here, y equals to 2, like this. Then you can draw your graph like this. Forgive me about the graph, as I'm using a freehand drawing like this. So in effect, what I'm trying to say is that once you can draw the original function, you can easily draw any function from the original function. Listen, you can easily translate any function from the original function. Does it make sense to you? Does it make sense to you?
Yes, sir.
Okay, good. So in the same way, domain and range, as I've told you, no matter what type of exponential function, the domain is always from negative infinity to positive infinity. But so when you come here, the problem is the range. So here, the range, because here is positive, is going to go from asymptote, which is 0, positive infinity. But when you come here, because now the number in front of the exponent is negative, it's going to go from negative infinity up to the asymptote, which is 0, not inclusive. Then here to still it is negative. Number 3. So it's going to go from negative infinity up to the asymptote, which we know is 2, up to 2, not inclusive. The last one here to the same thing. The range is going to go from negative infinity up to 2, which is the asymptote. But now the domain is always from negative. The domain, no matter what type of exponential graph you are dealing with, the domain is always from negative infinity to positive infinity. Don't let us forget that if it's the inverse graph, you always have to swap the domain and range. The domain becomes the range, the range becomes the domain. This is an inverse function. Okay, good. So when we come here to, we have to know that this time our graph is a decreasing function. Why is it a decreasing function? It's a decreasing function because the base is between 0 and 1. So in this case, the original function will still have an asymptote of y equals to 0, y equals to 0, but it is going to have a y-intercept of 0 and 1. At this time, our graph is going to be a decreasing function like this. And when you multiply by 2, it's going to expand a little bit, but it's going to still pass through like this, 1, 0. Then once you negate it, it will now reflect on the x-axis. So the graph will now become something like this. So it's just like the same thing that we know. Then once you say negative 3, it will go down by 3 units. So now this your point will now become minus 4. Your asymptote will now become minus 3. Obviously, because originally your asymptote was 0, so it will now become minus 3. So your asymptote will now come here like this. Then you can draw your graph. Sorry, I don't have space, but then you can draw your graph. It will pass through minus 4, and your asymptote will become minus. So it is the same. So you just have to get a general understanding, and you can easily do this test without any difficulty. And you have to know that minus 2 simply means that the graph is going to shift to the right by 2 units. Please, any questions? Yes, Zulu.
Yes, sir. I just want to make sure if we multiply the base with the like in number 8, if you multiply the base with -2, the graph would expand, right?
Yes.
So the greater the number that you multiply the base with, the more the graph expands, and the smaller the
Yes.
number that you multiply the graph with, the
They
more
shrink.
it shrinks.
Yes.
Oh, okay.
Yes.
I just wanted to double check that, sir.
Okay, good. So if it is less than 1, it starts shrinking, obviously, from the original graph. If it's greater than
Yes, sir.
1, it starts expanding from the original function.
Okay.
Is any questions again? Please, any questions again? We can see it from here. Yeah. Here, when the base is bigger, the base, it shrinks to the right. But then when multiplied by a number, it increases. Please, any questions again?
No questions.
Okay, good. So, please, the next thing we'll talk about is what we call the natural log. Now, the natural log is just like is then I don't want to bother you with the theory of how we got the natural log. And then the natural log is on your graph. You will see something like this: e exponent x. Like this, y equals to e exponent x, and it's called the natural log. And the value of this e is it's an irrational number, which is 2,7 something something, so many numbers. So you write that on the calculator. If you punch e exponent 1, you are going to get 2,7 something 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 something, so many numbers. So now, if we want to convert natural log into what do you call it? This is when it is in exponent form. But then if we want to change it to what do you call it? If we want to change it to logarithm form, it's written as to be written as x equals to log e y. Everything. That's like the way we converted exponent to logarithms. But this log e is called a lane. It's called a lane. The calculator use we call a lane y. Everything. So the idea is the same as normal exponents, just that the only difference is that this log, the base e, is called a lane. And the lane is what we call the natural log. The lane is what we call natural. So that is all about natural logs. I don't think that you can look at the proof later. But apart from that, everything holds like the original for good. Now look at how they have written this. Everything. Now the natural log is given by the original will be y equals to e exponent x. Everything. That will be the original function for a natural log. So if you are drawing this function, you are going to have something like this. If you are drawing this function, you are going to have something like this. Like this. Because the number in front of the exponent. This is also an exponent. The only difference is that it's a natural exponent or it's a natural log. But every rule that we have taught initially holds like this one. So this graph is going to be an increasing function. So once they have seen the rating something like this, at times they simply try to confuse you. But you are the one who is supposed to know that it's the same as minus e x minus 2 plus 2, which simply means that this graph is going to reflect, first of all, it's going to reflect on the x-axis. Then become something like this. It's going to reflect on the x-axis to become something like this. Then it's going to move to the right by 2 units. It's going to move to the right. So this point will move to the right by 2 units. It's going to go up by 2 units. So now your new asymptote is going to be your new asymptote is going to be 2, because it's going to go up by 2 units. So it's going to be y equals to 2. Y equals to 2. Now, this is your point, minus 1 will come here. Then your graph would look something like this. So it's the same as what we know about. You see that it has been done here. Obviously, it's the same like what we know about normal exponential functions. That is Once you know the original function, you can always translate the original function to get other functions. Please, any questions? Abelo, is the screen okay?
Yes, the screen.
Okay, good. And please also have to note that the rule I have already told you for domain and range also holds here. So in effect, for every exponential function, including the natural log, the domain is always from negative infinity to positive infinity, no matter how the exponential function looks like. So far as it's an exponential, yes, Abelo. Abelo, your hand.
Dear, I want to know that, for example, you are given the graph there. They said sketch the graph of f of x equal to 2 minus the e to the base, I mean e to the exponent of x minus 2. So I want to know if is it wrong to plot it straight away without undergoing the original function, without firstly identifying the original function, then you translate. Is it wrong
So
to, or
it is not.
they
It is
just want
not
the
wrong.
procedure of you knowing the original function?
The
Sorry?
most important thing is that your graph is correct. Exactly. But for some reason, for some reason, for some reason, you must always, for some reason, you must be able to trace from the original function. You get my point? If you can sketch it directly,
Okay,
that's
okay,
wrong.
fine. I understand it,
For
but
some
I
reason,
just wanted to
it is
know that.
always important to know the origin.
Uh-huh.
Okay, good. Okay, thank you very much. Okay, good. Any questions again, please? Okay, good. So please, a rule on domain and range will not change. Will not change. If you have y exponent x, the domain is still from negative infinity to positive infinity. But the range for this one, because the number in front of the exponent is positive, is going to be from the asymptote 0 to positive infinity. 0 to positive infinity. So even if the graph is like this, x minus 2, your domain still remains the same from negative infinity to positive infinity. But your range will still be from, you simply look at the number here, your asymptote is still 0. The number here is still positive. So it's still going to be from the asymptote 0 to positive infinity. But then if you have something like this, your domain is still going to be from negative infinity to positive infinity. But here now, the number in front of the exponent is negative. So your range is going to be from negative infinity to the asymptote, which is now 2, like this, for this graph, for this one. So you just have to generalize these things ahead, and you can always determine the domain and range of any exponential function. You can draw any exponential function, or you can picture any exponential function in your head. Any exponential function in your head. So just like here, you know that the original function, we have e2x minus 1. The original function is still going to be how do I put it? Um, um, the original function is going to be, we know the original function is going to be 2, um, um, it's going to be e exponent x. It's going to be e exponent x. And we know that the, with, what do you call it? The asymptote being, with your asymptote being the, how do I put it? Your asymptote will still be y equals to 0. Your asymptote will still be y equals to 0. And y, and there will be no x-intercept. And your y-intercept is going to be 0 and 1. So y-intercept is going to be 0 and 1. So that now, if you can look at this graph, if we can look at this graph, we have e equals to 2 exponent. We are, this time we are having e y. So let me draw this again. Our original function is like this. It's going to be like this. I mean, so our original function is going to be an increasing function. Then it's going to go like this. It's going to go like this. So now, if we have, this is e exponent x, we've seen that. Now, when you are multiplying by a number greater than 1 on the x, it's the other way around. Now, if the number is greater than 1, the graph will shrink. If the number is less than 1, the graph will expand. So if we have, sorry, this one is e exponent x, sorry, e exponent x. So when you have e exponent 2x, e exponent 2x, your graph will shrink a little bit like this. It will still pass through this thing, 0 and 1. Your graph is going to shrink a little bit like that. And if you have e x minus 1, your graph is going to move to the right by 1 unit. And if you negate it, it's going to reflect on the x-axis. Then if you add 3, the graph is going to go up by 3 units. The graph is going to go up by 3 units. So you can just use the original function of e exponent x to get 10. Understand me? You can just use the graph of e exponent x to get anything on the graph. Can we all see that? Or are there any questions? Yes.
No questions.
Okay, good. Okay, so well, you can just use that one to get anything. And also you have to know that the theory on the domain and range of an exponential function does not change. It's still the same. It's still the same. It doesn't change. It's still the same. Okay, good. So next thing you have to note that we talked about we already, when we started, we first talked about the relationship between an exponent and a logarithm. We talked about the relationship between an exponent and a logarithm. That is, for instance, if you have equals to a equals to b exponent x, it's an exponent. In terms of logarithms, x will be equals to log log BA log BA like this. X will be equal to log BA like this. So these are the relationship between exponents and logarithms. So we have to take note of these exponents, and you have to know that I told you initially, whenever log, whenever it is in a log is in the base 10, it's just like writing it without. For instance, if I write log 4 and I don't put any base here, you must assume that it is in base 10. You must assume that it is in base 10. But if I write log 4 equals to y, you have to know that it is the same as n exponent y equals to 4. When you don't find a base here, you must assume that it is in base 10. Then, as I told you initially, a log of e is the same as the natural log, which is ln. The log of e is the same as the natural log, which is ln. So we must take note of that. Then, once we know this, then we can now start looking at inverse graphs. Now, inverse graphs, it is not so strange from once you know the original graph, the inverse graph is just a mere formality. It's just a mere formality. For instance, if I ask you to draw a graph y equals to log 2x, you simply have to know that this is an inverse of an some original graph somewhere. It's an inverse of some original graph somewhere. Then we have to note that in that case we can easily convert these to exponents where we get 2y exponent y equals to x. And we know that inverse x and y is always interchanged. So we can simply say that y is equals to 2. So in that case, if you can know the original function, that my original function is we have 1 here. My original function here is 0 and 1. Then my asymptote is y equals to 0. And I know that my graph is an increasing function like this. Then straight away, the index graph, which is this one, you have to know that now this my 0, 1, you always interchange x and y. So here will be 1, 0. And now my asymptote will now be x equals to 0. Then here we saw that this graph was an increasing function. X was increasing, y was increasing. So the inverse function too, it must be the same thing. As y increases, x, as y increases, x also increases.
So you're breaking.
Am I audible now?
Yes.
Okay, good. So as x increases, y, so in this case we do the other way around. As y is increasing, x must also increase. Then you have your graph like this. See, so the original graph is always the basis of everything. Listen that. Once you can get your original graph, you can get so many byproducts from your original graph. Have you seen? So in this case too, for the original graph, you know that your domain, as I say, no matter the exponential function, is negative infinity to positive infinity. And your original graph, because your number in front of the exponent is a positive, your range is going to be from the asymptote, which will be 0 to positive infinity. So the domain and range of the inverse graph, which is log s, you simply interchange domain and range. This time your range and your domain is going to be, for the inverse, is going to be from 0 to positive infinity. And your range will be from negative infinity to positive infinity. So that is the power of the original function. That is the power of the original function. Once you know the original function, you can get so many byproducts from the original function. Please, any questions? Please, any questions? Please, any questions?
No questions, sir.
Okay, good. Now let's go on. When we have this one we have we are asked to sketch this graph. Why? So once we see its log, we have to know that it is an inverse of some exponential function. Y equals to log half x. Half x. So converting this to exponents, we are going to have 1 over 2 all exponent y equals to x. Then remember that inverse, we always swap x and y, so y will be equals to 1 over 2 all exponent x. Then from here, once you know the original graph, let us remember from the beginning that we said that if your base is greater than 1, your graph is an increasing function. And if your base is between 0 and 1, your graph is a decreasing function. So in this case, this graph is a decreasing function. This graph is going to be a decreasing function like this. This graph is going to be a decreasing function like this, where we have, so as x increases, as x is increasing, y is decreasing. So now if you want to find the s, now the point will come here, 1. Then your asymptote will now be x equals to 0. So with the inverse to now, remember the original, as x was increasing, y was decreasing, it's a decreasing function. So in now with the inverse, now as y is increasing, x must decrease. So now that means that your inverse is going to come like this. Your graph will now come like this. Have you seen? In the sense that as your x is increasing, your y will be decreasing. Oh, sorry. Or as your y is increasing, your x will be decreasing. Remember that we are doing the inverse. The original graph, as x was increasing, y was decreasing. So the inverse, as y is increasing, x must decrease and approach the asymptote. We have the inverse graph. And the domain and range too is the same procedure. Please, any questions there? Okay.
No questions.
Okay, so in the absence of no questions, please, all these are the same. Obviously, once you know the original graph, you can always find the inverse. So you need to go with a generalized mind, and you can't be able to draw any graph. So I would like us to look at this graph. We have f of x, and here we have log 3 log 3 x plus 1. Now, of x is the same as y, so we can get 3y, 3 exponent y equals to x plus 1. Then remember that we always interchange x and y for domain and range. So we can say that 3x, or we can say that, okay, 3x equals to y plus 1. Then y equals to 3 exponent x minus 1. Now, the original graph will look like this. And we have to note that if we are starting with the original graph, it's 3 exponent. The number here is positive. So we are going to have 1 here. So our graph will look like this. Increasing function, because the number in front of the x is positive. But it is minus 1. If it is minus 1, it means that your point will come here, 0. Then your original asymptote, which is y equals to 0, y equals to 0, will now become y equals to minus 1. So your asymptote will come here. Your y asymptote will come here. Y equals to minus 1. Y equals to minus 1. So your new graph is going to be like this. Your new graph is going to be like this. Then from here, we can now, so we have plotted the original graph. So now if it comes to the inverse, it is the same thing. Now you know that, what do you call it? Now we know that with this graph, you know that your asymptote was y equals to minus 1. So now if it comes to the inverse, your asymptote will be x equals to negative 1. X equals to negative 1. Equals to negative 1. And the point here was 0 and 0. So if you interchange it, it's still 0 and 0. So it will not change anything. And here, we know that as x was increasing, y was increasing. So in the same way, the graph will pass through 0, and as x increases, y increases. Then you get your inverse. Then you get the inverse graph. Listen, there are other variants, but it's the same thing, whichever way you do it. But what you have to see is that everything was traced from the original exponential function. We were able to trace to get the variance or the derivatives of the exponential function. Then we can be able to use that to get the inverse function. Excuse me. Now, in the same way, if you can look at this graph, you can see that if you can look at this, oh God, I've cleaned this thing. If you can look at this graph, which is y equals to 3 exponent x minus 1, we can see that the domain is going to go from negative infinity to positive infinity, and the range is going to go from how do I put it? There is going to go from the asymptote, which is 0 to positive no, the asymptote, sorry, the asymptote now is negative, what do you call it? The asymptote now is negative 1, so positive 1. So it's going to go from, negative 1. It's going to go from negative 1 to positive infinity. So when you come to the inverse graph, the domain will now simply be from negative 1 to positive infinity. You just interchange, and the range is going to be from negative infinity to positive infinity. So that is why it's more easier to understand it if you trace from the original function. Please, any questions? Any questions, please?
No questions.
Now, okay, good. And you also have to know the laws of logarithms, the laws of natural logarithms. They are no different. They are the same. Laws of logarithms and the laws of natural law. So if you have ln mn multiplying, it is ln m plus ln n. If you have ln n over n dividing, it subtracts, it will be ln n minus ln n. Then if you have ln n exponent k, the k can come forward, it will be k ln n. Then ln and e will cancel out. So ln e is the same as only x. The ln and the e always cancels out because one is the inverse of the other. So it always cancels out. And in the same way, we have y ln x, the ln and the y always cancels out. So we are going to have x the same way. So this you must make yourself conversant with the laws of logarithm, which is no different from the laws from the natural law. So the first one, if you have lane one, without using a calculator, what is going to be lane one? That lane one will simply be 0. Why am I saying lane one is 0? Because for example, if I have log 1 or log to the base 10 1, it's the same as 0 because n exponent 0 is 1. So lane 1 is 0. Then when you have lane E, the lane will cancel out the E. So you are going to have 1. The lane will cancel out E. So you are going to have 1. When you have E exponent lane 5, the lane will cancel out the E. So here too, we are going to have, that's the answer to be 5. So in the same way, we have lane EI. the lane will cancel out the E, so we are going to have I. And here we have E 2 lane I. From the laws of exponent is E exponent lane I squared. So the E will cancel out the lane. We are going to have I squared. Then here we have lane E 3 exponent 3x. So this will cancel this one. We will simply have 3x as the answer. Then the last one is to obviously be square root of x as the answer. So this is not anything that should give you much stress. It's not anything that should give you much stress. Okay, number 8, we have what do you call it? E I'm not so sure whether this is negative. Let me see. Okay, so it's the same as negative 2 lane x. So we have to know that this is the same as E lane x minus 2. So this will cancel this one. So our answer will be x exponent minus 2, or is going to be 1 over x squared. So the next one we have log 3 exponent root 3. Now from the laws of log, we can have it the same as root 3 log 3. Now log 3 is the same as 1. So our answer will simply be root 3. Then our next one, we have then we have the next one, we have this E lane x all squared. So board mass, we do the one in the bracket first. Board mass, we do the one in the bracket first. So we have to note that this will cancel this. So we are going to have x squared. So our answer will simply be x squared. Our answer will simply be x squared. Then our next one, we have lane into bracket E exponent x over E x minus 1. Board mass, do the running bracket first. You have to know that this is the same as EX over EX minus 1. And this ES will cancel the ES. Let us remember that it is all embroidered in the lane. This ES will cancel this EX. So we are going to have lane into bracket 1 over E minus 1, which will be the same as lane E. This will cancel this, which will be the same as 1. Please, any questions? Okay, so please, you need to look at this one, which are common mistakes that most of you make. Please, lane M over N is not the same as lane M. It's not the same as lane M. Lane M divided by lane N. They are two very different things. It is common mistakes that most of you make. Then in the same as lane M plus N, some of you, when you see lane M plus N, you just say that it's the same as lane M plus lane N. No, it's not true. It's not the same. It is only when it is lane N that is the same as lane M plus lane N. So you must also take note of that. Okay, good. Then last one. When you have lane M, all exponent P, it's not the same as bringing the P forward. It is only when it is like this, lane M exponent P. That's when you can bring the P forward. But when it is like this, you cannot bring the P forward. So please, you must note some of these errors that you make. Any question? Any questions? Okay. So when you have lane 3 plus S, you have to know that it's like the other way around, it's the same as lane 3x. When you have lane x minus lane 2, the same as lane x over 2. You can go the reverse of the law. Then when you have 2 lane x minus 2 plus, it's the same as x minus 1 all squared, lane x minus 1 all squared over x exponent half. Then you can times lane n times x half like this. You can go the law in the opposite direction. So please, it will be very easy for you to do this. Please do them yourself, and you can find the answers at the back of your book. I think the answers are even here. And here too, you should be able to, when you are to solve it here, the lane will just go away. You can just cancel out the lane. Then you just solve the x. And here, you have to know that lane a plus lane x is the same as will be the same as lane 3 2x plus minus 1 equals to lane x plus 1 all squared. Lane x plus 1 then you can easily cancel out the lane, and you solve it quadratically. It has been solved here. It has been solved here, so you can easily see it. It has been solved here, so you can see that. Yeah. So please, The rest, I should believe you can do them on your own. I should believe you can do them on your own. So do the examples in the book before you attempt the test. So, in the absence of no questions, I would like to bring the class to an end. All the exercises there, you can find the answers in the book. So it is imperative that you try it yourself. If you are having any challenges, then you contact me. Exactly. So please, are there any questions before we close the class? Are there any questions? Are there any questions? Okay. So in the is there any question? Yeah. What's the question? What's the question? Okay. In the absence of no questions, then please, we are going to bring the class to an end. If you are solving any question and you have any challenge, you can contact me privately. Thank you very much, and good luck in your last class test.